Okay, so in our last explainer, we landed on a really critical point. That thing the ancients called qi, it isn't some mystical force. It's actually a combination of measurable physical forces. And, the second you prove that qi is physics, a door just swings wide open. Because if you can measure it, well, then you can engineer it. For something like 2,000 years, the acupuncture needle was probably the most advanced piece of medical tech on the planet. I mean, it's a perfect tool. It's the simple, conductive metal rod that slips through fascia, creates a tiny piezoelectric spark, and basically acts like an antenna for the body's entire electrical grid. But let's be real. As amazing as it is, it's a stick of metal. It's the version 1.0 user interface for the body's operating system. So, that leads to the obvious question, right? Can we build a version 2.0? Can we create a machine that doesn't just read qi, but actually generates it on demand, without ever having to break the skin? Well, the future of this medicine is happening right now. And the tech giants in Silicon Valley, even the research labs of the US military, they're already building it. But hang on. Before we get to all the shiny new hardware, we have to build some trust. So we're going to do something a little different. We're going to tackle the three biggest, most honest, skeptical arguments against this technology right up front. First, what I call the 1982 problem. You're going to hear this statistic everywhere, that microcurrent can boost cellular ATP, the energy fuel for our cells, by 500%. But that number, it comes from a single study from over 40 years ago. And here's the kicker. It was done in vitro, on isolated rat skin cells in a petri dish, not in a living, breathing human. A skeptic is right to ask, if this was so incredible, why isn't it standard procedure in every hospital today? It's a fair question. Second thing we need to talk about is the regulatory stuff. A lot of the devices we're going to cover are FDA-Cleared, not FDA-Approved. Now that might sound like the same thing, but believe me, they are worlds apart. To get cleared, a company just has to show their device is basically similar to another one that's already out there. It does not mean they have to do new clinical trials to prove that it actually works. That's a huge distinction. And finally, there's the DARPA factor. You'll often hear that DARPA, the military's high-tech research group, is funding this stuff, and it's used as a stamp of approval. But let's be really clear here. DARPA funds thousands of risky, pie-in-the-sky projects. Their investment means the physics behind an idea is interesting. It absolutely does not mean it's been proven to work in a clinical setting. It's an appeal to authority, not an appeal to actual evidence. Okay, so objections are on the table. We're going to keep them in mind as we go. Now, let's get to the main event. It's time to unveil the version 2.0 hardware arsenal, 4 incredible technologies that are upgrading the needle for the 21st century. All right, first up, microcurrent. And let's get this out of the way. This is not a TENS unit that just buzzes and shocks you. Microcurrent works at a subsensory level. It's like a whisper of electricity, so subtle you can't even feel it. And instead of just trying to block pain signals, it's designed to go straight to the source and help with cellular repair. We're literally talking about recharging your cellular batteries from the outside. And there it is again, that 500% ATP number. Now, yes, we know it's from that 1982 in vitro study. But the underlying mechanism, it's been confirmed again and again. That same study also showed a 70% jump in protein synthesis. So while that big 500% number isn't clinically proven in humans, what we have seen replicated is that these currents do consistently speed up wound healing and tamp down inflammation. The point is, the mechanism itself works. But it gets way more precise. If microcurrent is the new hardware, then think of frequency-specific microcurrent, or FSM, as the software. This is basically programmable acupuncture. It uses 2 channels at once. Channel A might deliver a frequency to tackle a specific problem, like inflammation. At the exact same time, Channel B sends a different frequency to target a specific tissue, like a nerve. We're talking about incredible precision here. Technology number 2, now we're swapping electricity for light. If the V1.0 interface was a needle made of metal, then the V2.0 interface is a photon. This is called photobiomodulation, or you might hear it called laser acupuncture. We're using carefully calibrated red and near-infrared light on acupuncture points to kick off photochemical reactions inside the cells, kind of like how a plant uses sunlight for photosynthesis. So how does light generate qi? It's really elegant. See, in a cell that's stressed out, a molecule called nitric oxide basically clamps onto the cell's power plant, the mitochondria, and chokes it off. But when a photon from the laser hits that spot, it physically knocks the nitric oxide molecule out of the way. Suddenly, oxygen can rush back in, the little assembly line starts back up, and boom, you get this huge, immediate surge of ATP. Our third technology is pulsed electromagnetic field therapy, or PEMF. Remember how twisting a needle squeezes the collagen and creates a little piezoelectric spark? Well, PEMF does the same kind of thing, but it squeezes every single cell in a targeted area all at once without ever even touching the patient. It's like an invisible, non-invasive pressure wave. And the way it works is just pure physics. It's all based on Faraday's law of induction. A coil creates a magnetic field that pulses and changes over time, and this field passes right through the body. As it does, it induces a secondary electric field right inside your tissues, perfectly mimicking a body's own bioelectric signals without any physical contact at all. Now, lasers and magnets are incredible, but they are still external tools. If you really want to see where this is all heading, you have to look at bioelectronics. This is the cutting edge, where the hardware isn't just a tool you apply, it's a device that's either implanted or worn. The needle is about to shrink down to the size of a grain of sand. I mean, just look at this evolution. It's stunning. On the left, you have the version 1.0 needle, and on the right, that's version 2.0, DARPA's neural dust. These are tiny wireless sensors about the size of a single nerve fiber. You inject them once, and they become a permanent wireless node in your body, powered from the outside by ultrasound. And this isn't just science fiction in a lab, it's already moving onto our bodies. There's a company called Nēsos that makes these immunotherapy earbuds. They stimulate the vagus nerve to treat rheumatoid arthritis. You've got Fisher-Wallace and Neurometrics with FDA-cleared wearables for things like anxiety and fibromyalgia. The whole idea of the clinic is being decentralized. A practitioner can literally prescribe and program a patient's qi from anywhere. So the technology is obviously powerful and it's here to stay. But this brings up a huge question. What is the role of the actual human practitioner in all this? What happens when the art of medicine collides with the machine? Let's imagine a conversation. You have the young tech evangelist, right? And they're arguing that we spent thousands of years figuring out where to put the needle, not just how. From this point of view, the needle was never really the point. It's just the stylus. The ancient meridian map, that's the touchscreen. And now we just have better styluses, lasers, magnets, and microchips. But then you have the voice of experience, the old master, and he pushes back. He says, when a practitioner puts in a needle, they feel things, the resistance of the tissue, the temperature of the skin. The needle isn't just sending a signal in, it's also an antenna receiving signals out. Information flows both ways. Your laser pushes light in, but what does it tell your hand about what's really going on with the patient? And this is the brilliant punchline. Even when you tell him that modern devices have biofeedback loops that can read things like tissue impedance, the master just kind of smiles. And he says, then you have built a very expensive, very smart, invisible metal stick. It's this great acknowledgement that all of this incredible futuristic tech is, at its heart, trying to replicate the elegant simplicity of the original tool. So, where does that leave us? Look, the simple metal needle isn't going away. It's too elegant, too cheap, too effective. But the very definition of what a practitioner is, that's about to get a whole lot bigger. This is the key takeaway. You're not a professional needle sticker. You are an engineer of the body's internal physics, a manipulator of biological currents. Soon, your clinic might use calibrated lasers to lubricate the body's tiny nanomotor, or use PEMF to tell blood vessels to grow. The ancient map was always the key, and now the interface we use to access it is finally getting a massive upgrade. So, the hardware has been upgraded. Next time, we're going to ask the question that I know everyone is thinking. What happens when we upgrade the brain? What happens when artificial intelligence gets its hands on the meridian map? Get ready to meet the AI acupuncturist. Can a machine read your tongue, feel your pulse, and pick your points better than a human ever could? We'll find out next time.